So welcome again, SC24 NeuReality. We're demonstrating our technology here, hardware and software, to optimize AI acceleration and AI compute. In this bench, we're going to show a performance, a live demo of our system running in the cloud, and we control it from here. What you'll be able to see here is the linear scalability that our technology allows. So no matter whether you use a single GPU, 8 GPUs, or 800 GPUs, you will always be able to fully utilize them to 100% utilization, unlike existing systems that are basing on CPU-centric architecture. So I'll go ahead and demonstrate. We're going to see the linear scalability that I mentioned that translates into cost of ownership and energy efficiency. And we're going to compare two system architecture. The CPU-centric, where the CPU is hosting the AI accelerators, the GPU. This is what everyone is using. NVIDIA, AMD, any AI accelerator is hosted by a CPU today and connected to the network via a NIC. In our technology, the NAPU, the Network Addressable Processing Unit that we innovated, created, patented, and taken to market, is hosting those exact same GPUs, any type of them. And you can see in the green light, when you use the old, outdated architecture that is basing on general purpose solutions, you're losing efficiency with every additional GPU that you want to use. So when you get to the 8 GPUs installed in an OEM server, you're down below 70% utilization in a small LLM. In computer vision, audio speech recognition, the loss is even bigger. So what you're going to see, and Or is going to show you when he connects to our cloud system, is two comparisons. Clients, remote clients, sending AI acceleration request to those servers. This is our chassis with the Qualcomm AI 100 Ultra installed in it. And we're going to see how much performance we get when we use a single GPU, when you use 4 of them, or when you use 10 of them. And you will see that we're able to reach 100% utilization agnostic to the type of GPU or to the amount of GPUs that we leverage in every system. Or will show us the performance with the dashboard. Each one of these meters will show us how much we can squeeze from each accelerator. And here we'll see the total amount that the server provides and the total utilization. The bottom line is that when we compare what's the cost of a million token and what's the energy consumption for the tokens that we're using, you can see lower is better when you talk about cost. And in this case, you can squeeze much more tokens for any invested wattage of power consumption. So we'll switch to the configuration. This is the configuration manager. We can select any cluster and any type of deployment, or we'll deploy Llama 3, 8 billion parameters into our server and deploy containers into the clients, remote clients running in virtual machines and running AI applications, sending AI requests to our server. Now we kick off the test and we're waiting for all the servers to be deployed. We're going to see the green light when they're ready. And on a different screen, we can see the clients that are deployed. So we don't just give acceleration capabilities, we give the cloud ecosystem software that does all the Kubernetes-based management of the system, deploying the different containers for the application side, for the server side, and then triggering the test to start and sending AI requests from all clients at the same time. The flow of the test will go, first of all, in this GUI, or can trigger one of the clients to start sending requests, and we will see that it stresses a single card, a single AI accelerator, and then he will send another command to run additional 3, so we can compare how much performance we get from a single client, how much we get from 4 clients, and then at the end will stress the system to 10 systems, 10 AI accelerators, and we will see the linear scalability picking up. Yeah, now the test is starting. This is the monitoring dashboard that we can use. And now a single client was triggered, and in a few seconds we'll see the monitoring start to collect data from the client side, from the server side, and we'll be able to see the performance starting to pick up. Yeah, so now we can see that two AI accelerators are being stressed, and it's starting to pick up. And we saw a single one running at 400 tokens per second generated by the Llama 3 8 billion per ARM pipeline that was deployed. And even when we go to 4 of them, we still see 400, and the total amount that the server serves right now is almost 1,600, so 4 times. And this gives you the utilization, almost 99% utilization. If we wait a couple more seconds, we'll see that the other 6 are being triggered as well. And all of them are in one server. And unlike the CPU-centric system, here we will see, the 5th is picking up, and we'll soon see all 10. And we're supposed to get close to 4,000 tokens per second, which is the maximum that the AI accelerators can drive. So the important thing here is that a customer that deploy our technology or consume it on the cloud, he gets every bit of performance, every bit of throughput that he paid for. Today, when you look on the deployed GPUs in the world, they're roughly around 30-40% utilization worldwide. So imagine the amount of cost and energy that we're losing in the investment that we've done. So going back to the graph, those two things translate into CapEx and OpEx. The capital expense is how much your application, how much performance your application need in order to serve your client base or your deployed use case. And this is how much servers you need to buy. This is how much electricity bill, power, and cooling that you need to invest. And in both aspects, you can gain an order of magnitude improvement to your bottom line. So that's in this bench. Thank you very much.